To control a value stream, data needs to be collected in real time. This is often done automatically by the equipment itself, but on some occasions, it must be done manually. Even on high-tech shop floors, you can still see pencil and paper data collection. You can read this article in Polyhedrica blogspot. Detecting aspect defects is often difficult to automate, even with automatic optical inspection. When an operator is required to inspect, we need a method to enter the results into the system. Line incidents, change of critical process parameters, etc. also need to be reported the moment they take place. This is a typical pencil and paper data collection process. The operator hand writes the defect data on a form. Forms are collected at the end of the shift. A clerk types the form's contents into the system at a later stage. The engineer analyzes the results and takes corrective actions while after the data is entered. These are some potential problems with pencil and paper data collection. It is time-consuming for the operator. Transcribing the data is non-value add. The operator's handwriting is not necessarily good. Errors may be introduced, both by the operator and the clerk doing the transcription. Some of these errors may be impossible to recover when they are detected. Real-time process control is impossible. Problems are detected long after collection. Maybe we have been producing bad products before the error is detected. This is a real-life example of a disaster caused by the misinterpretation of handwritten data. In a large hospital, a doctor's prescription was misinterpreted by the hospital pharmacy due to the missing, or not clear, decimal point in the dose. As a result, a child was administered a dose 10 times the intended value, and this caused his death. There were, possibly, other escapes by the pharmacy, nurse, etc. who did not detect the mistake. But this is an example of a terrible consequence of misinterpreting handwritten data. The alternative to the pencil and paper data collection is, of course, directly reporting incidents in a terminal the moment they happen. You can provide terminals in the inspection and test stations to do that. Sometimes it is difficult to provide individual terminals to all the operators who need to report. Sharing terminals and having to walk to the nearest terminal is time-consuming, so it may not be acceptable. The reporting operation should not be time-consuming and error-prone. If we ask operators to type 12-digit numbers or timestamps, the chances of error are very high. So, we need a reporting system which is both simple and error-free. Large number typing can be replaced by a QR code, which can easily be read with a smartphone, to enter it into the system. We can use the data validation alternatives provided by Excel. In this way, reporting errors may be detected the moment they are entered and corrected on the spot. Pull-down menus may be used for each field to avoid typing and ensure all use the same wording. Using a unique wording to describe an event is important when it comes to analyzing the frequency of each event. Associating a timestamp to each data entry can be very useful for problem analysis, to identify when it happened, and detect cause-effect relationships between different factors. Since this can be done automatically, it doesn't add any cost or delay. Critical numbers such as a bank account IBAN number can be easily validated with a formula the moment it is entered, so that it is immediately rejected if the calculated check digits don't match. Having a terminal for each operator who needs reporting may not be possible, in which case, reporting on the cloud with the operator's own smartphone may be an alternative. The database can be created in a spreadsheet in Google Drive, OneDrive, or Company Web. Reporting may be done with any tablet or smartphone via Wi-Fi. Operators may have difficulties in producing readable handwriting or reporting in a terminal, but they are normally experts in typing into their own smartphones. This existing widespread skill can prove very useful for real-time online reporting. When a problem is detected, it can, immediately, be reported with a phone from anywhere, and the moment the problem is resolved, this can also be reported on the spot. The smartphones used may be the operator's own device or one supplied by the company. It, obviously, requires appropriate firewalls to avoid entering a virus. Even a smartphone with no telephone line may be used to access via Wi-Fi. An old out-of-use smartphone might do the job. To avoid corrupting the database, each workplace may have a dedicated input worksheet in the cloud, and then data is automatically transferred to a central worksheet. Operators need write access to their input worksheet and read-only access to the central worksheet and reports. Data, both text and numbers, can also be entered by voice with an ordinary smartphone. To control your weight, you can use this Excel SPC in the cloud with your smartphone. You enter your weight and immediately find out if there is a statistically significant trend up or down. Apart from checking if your weight has gone beyond the upper or lower control limits, other checks for trend symptoms are applied. In this case, looking at a graph is not necessary for your real-time control. In this example, you have a significant weight increase trend starting on June 9th. Real-time data collection enables real-time feedback to the operators to take corrective actions while it is still possible. This and-in display provides real-time feedback. PTH component insertion 4124 DPMO in red means it is above the 1500 maximum target. PTH component solder 32 DPMO in green, it is below the 190 maximum target. Average process flow is 13 cards per hour. SPC charts are another alternative to provide feedback to the operators in real time. When this feedback is in real time, it is possible to relate changes in the output to what just happened in the line, change in process parameters, line incidents, etc. This makes it possible to get to the root cause of problems and often solve them on the spot. In complex projects, where multiple people and organizations are involved, it is essential to keep everyone up to date in real time. Since jobs are interdependent, any delay can affect several jobs downstream. They all need to know when the preceding jobs are completed to plan their own. Access to the updated schedule anytime, from anywhere, is easy if the project schedule is in the cloud and accessible by all participants with their smartphones. These are some conclusions. Pencil and paper data collection makes it impossible to provide real-time feedback to the operators. All we have is after-the-fact compound data. In this case, it will be difficult to find the root cause of the problem, and therefore the problem will often remain unresolved. All we can do in this situation is guess what happened and try to find justification for management. With pencil and paper, data is often missing, and there are errors which often can't be recovered. Data entry errors, if not detected in the moment of entry, may be impossible to recover. Data may be easily entered into a spreadsheet in the cloud, via Wi-Fi, using an existing smartphone. Direct data entry into the system enables automatic data validation, which will request the operator to enter again, in case of a typing error. These are some related articles.